I'm Danny Shapiro. I'm the Senior Director of Automotive at nVIDIA. nVIDIA is a technology company that's developed a lot of different computing platforms. Specifically, we've developed an AI supercomputer for self-driving vehicles, whether they're cars, shuttles, trucks, or any kinds of other vehicles that we'll soon see on our roads and maybe even in the skies above us. So nVIDIA is not making cars, but nVIDIA has its own fleet of self-driving test vehicles. And we've dubbed it BB-8 as an advanced robotic vehicle. And we're testing those here on the streets in California, out in New Jersey, in Germany as well. Well, we've been working with the auto industry for almost 2 decades now. In fact, every car, truck, plane, or other mode of transportation, and even consumer goods are designed on NVIDIA graphics, hardware, and software systems. About a decade ago, we started bringing our technology into the car. We started working on infotainment systems and digital cockpits and head-up displays. More recently, though, our technology, because of the role we're playing in artificial intelligence, is being used for self-driving vehicles. So instead of us generating information out in the form of pixels on displays, we're also now processing information coming in. So radar, LiDAR, camera information all comes in to the NVIDIA system, and we're using artificial intelligence now to make sense of it. Now we have a specific product just for vehicles, and it's called DrivePX. It's an AI supercomputer that has the power of over 150 MacBook Pros, all in a very small form factor, about the size of a license plate. Essentially, all the inputs come in to the DrivePX, from cameras, from sensors like radar and LiDAR and ultrasonic, all generating data. So our processor has to take all this information and make sense of it. Basically identify what's another vehicle, what's a pedestrian, what's a crosswalk, what's a sign, and all this happens within a fraction of a second. We have cameras generating 30 frames every second. We have to analyze those frames and understand a full 360 environment around the vehicle. The GPU, or Graphics Processing Unit, was invented by NVIDIA in 1999. This is a massively parallel processor, and it's different from a CPU, or Central Processing Unit, that you find in your PC. You've probably heard a CPU described as a dual core or quad core. And so essentially that means there's 2 lanes or maybe 4 lanes of information that will flow through that CPU at once. The GPU, on the other hand, has now over 5,000 cores. So imagine if this was a highway, instead of a 2-lane highway or a 4-lane highway, we now have 5,000 lanes. So a lot of traffic, a lot of information can go through that processor simultaneously. And then we're able to bring all that computational horsepower down into the car in the DrivePX to be able to process all the sensor data in real time. DrivePX 2 is one of several products from NVIDIA that are all using deep learning. So we have the system for the car, but other people who are developing can develop on a PC. You can use deep learning in the cloud, or our embedded device called Jetson if you're a hobbyist or a maker. The benefit of this unified architecture is, again, you develop on one platform and you can deploy it on any platform. And so I think that's the challenge today, is for students and now the industry to develop new algorithms, new deep neural networks, and leverage AI to build a complete self-driving car system that is specific to the vehicle. Given the types of jobs out in the marketplace today and the lack of talent, I think there's a lot of opportunity for anyone just getting started who can take courses to understand the fundamentals of computing today. And now there's a whole number of things that are unique to the self-driving challenge. So understanding the complexity of what happens throughout the computing pipeline of developing a self-driving car will be essential to getting a job in this industry.